Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back again to the NPTEL online certification course on research methodology for planning and architectural studies. In our last lecture, we have discussed about hypothesis testing, and I hope that you have gone through that particular content and things are clear to you. Today, we will be discussing about parametric test, where looking at the data and type of data, we will decide upon whether you will go for parametric test or non-parametric test. So, we will be discussing this parametric and non-parametric test in our next two lectures. So, today at lecture number 37, we will be discussing mainly on the parametric test, and I will show you some example for some of the parametric test. Definitely, as there are n number of tests available, there are different kind of statistical handbook that you can refer, or maybe there are other few courses available where you can get through all those statistical tests. So, as because the scope of this particular course is on the research methodology preliminary, so I will give you some demonstration, but definitely not all the parametric tests which are available to us. Okay, so with that let us start. We will discuss about parametric test, examples of parametric test, and we summarize our understanding. So, if you recall, when we discussed about the type of data, that time we discussed about basic 4 type of data like nominal scale data, ordinal scale data, interval scale data, and the ratio scale data. And as because nominal and ordinal, they are just showing some sort of order or category. In case of nominal data, we cannot essentially go for some kind of parametric test. So, for that we will go for non-parametric test, whereas the interval and ratio scale we can take the parametric one. So, this is the basic idea about when to perform parametric and non-parametric test for your research. Now, parametric and non-parametric test. So, parametric test relies on statistical distribution in data applicable to ratio and interval scale data. So, your data will have a particular distribution. So, in previous class we have discussed about normal distribution. So, the data are distributed normally, so with a mean or standard deviation, but in such case only ratio and interval scale data can be taken into consideration. Examples that we can go for t test, then you can go for z test, you can go for some sort of ANOVA through F test. It may be also like some sort of Pearson correlation, then regression analysis, and there are so many like where you can apply your statistical test to bring out the required findings, or maybe you can establish the relationship between variables, or maybe you can establish the trend, or maybe you can in line of your like our previous discussion, that you can test your hypothesis, null hypothesis for your study, where non-parametric tests do not depend on any distribution, usually applicable for nominal or ordinal data. An example where you can go for chi-square test, you can go for Wilcoxon test, it can be Mann-Whitney U test, or it may be Kruskal-Wallis test, then Friedman test. So, there are other options as well. Even you can also go for the Spearman rank order correlation as non-parametric test. So, mainly in this particular lecture we will be discussing this parametric test, and then in next lecture we will take about the non-parametric. Now, for the parametric test, definitely one set of test which is almost similar, that is your J test, and then you can say the T test. So, based on the normal probability distribution, we consider this that it is an appropriate test for judging the significance of the sample mean or for judging the significance difference between the means of two sample. Okay. So, where you can go for T test as well. Now, F test is based on F distribution, and this is used to compare the means across multiple groups or conditions. Suppose in a particular company you have say male female worker, and then you just try to understand that their performance or their salary, etc. So, in those cases you can also go for some sort of analysis of variance test, and then you can follow the F distribution pattern and try to check it. Then you can also go for this kind of Pearson correlation, where it is one of the most used method where you try to check the correlation or the relationship between two variables. As I already mentioned earlier, you can also go for linear regression, where you can check the relationship between dependent variable and independent variable, and as a measure of performance of those regression, you can have different statistics, or maybe you can also calculate in those cases the most common representation to the goodness of fit or the R square value. Now, coming to the Z test. So, again this is very similar. Now, probably we are very familiar with this particular graph, where within this particular region, this is you can say the confidence interval, and then also the acceptance region, and then other two are where it is taken as alpha by 2, where alpha is the significance level. So, normally we check at the 5% significance level, where the corresponding Z value is plus minus 1.96 for a two tail test. So, there are other few one tail test and all. So, for two tail normally we go for most of the cases. So, I am referring that value. Now, in this case the Z test and T test, they are almost look like similar, but there are certain kind of basic assumption where you can go for Z test or T test. If you go 1.96 standard deviation above and below the mean, you will capture approximately 95% of the data. So, that is basically the confidence interval. So, Z test is used for large sample, and where T test can be used for a small sample. So, whenever you have population data, or maybe the data is almost close to the population, and you also know those kind of population parameters like the mean or variance. So, you can also go for Z test, where you have this equation like where you have this mean, where the Z test, this is the mean of that particular large sample, and this mu H0 is nothing but that particular the null hypothesis, that where you assume the mean should be like this. So, for a particular case, if the actual mean is say 50 and you assume that 45, so this is basically to test it. But for that, for this population or the big large sample, you also need to calculate the standard deviation. Okay. So, how to calculate the standard deviation? So, this is basically the formula, and definitely I will just write another one where it is for the entire population. So, you get the formula like this. So, in this case definitely what you do, that you try to make the sum of squared of difference, the variance, and then you just divide it by that particular sample, and normally in a small sample we go for n minus 1 and calculate that value. So, that is basically the variance, and standard deviation, as I already discussed earlier, is the square root of the variance. Now, as your sample will be higher. So, then in this case n minus 1 is almost close to the n. So, maybe if the total population you are considering is say 50,000. So, 50,000 minus 1 49,999 is almost like the same. So, in that case we can go for taking the n where we know the parameter, otherwise we go for it. So, for t, that is why there is no much change of this particular formula, where you have the assumed value or hypothesis like null hypothesis value, and then this is the sample mean, here it is the population mean, it is the sample standard deviation, it is your population. Now, in this case you can refer that okay, how you are calculating this value. So, it is about the number of sample, right. So, for standard deviation only we are having this kind of change in the equation, but in this case test statistics it is the number. Now, let us understand this particular example, like the sample population density is 90% per hectare in hill cities. So, where we assume that mu or the mean is 90, alternative it is not 90. So, that is the assumption. So, there are some kind of 10 cities here we are taking, and where you have the values 35, 75, 125 like that. So, somewhere it is more, somewhere it is less, and then the mean of those all values are nothing but 93.5 people or person per hectare. So, what we need to do, first we need to see the difference. So, if you consider this is a small sample, so you go for a sample related standard deviation. So, where the corresponding value xi is nothing but all this value, right, and then mean value already we have calculated. So, this is nothing but the x bar. Now, you try to make the difference. So, how we are getting this value? It is 35 minus 93.5. If we consider this, so then again xi is 115 minus 93.5. So, like that you will see the difference. So, somewhere it is positive, somewhere it is negative, and if you sum all of them, so sum total will be 0, you can check it. But here we are going to take basically the sum of square difference. So, you are getting the value whether it is negative or positive, it does not matter. When you square it, you will get always the positive value, and then you take the summation. So, in this particular summation you get this value as 17652 17,652.5, and then this is nothing but n. So, n minus 1, and if you calculate you get the standard deviation as 44.29. Up to that you are done. So, you would able to make this calculation. You can cross check this calculation at your end. Now, we have those kind of value, input value, that standard deviation is 44.29, mean is 93.5, the null hypothesis where mean is 90 and the sample is n. This n is equals to 10. Now, we know this particular equation as I already presented. So, we just substitute those notation with the value. So, x bar is 93.5, mu 0 is 90, standard deviation is 44.29 and n is 10. So, if you calculate it, you will get the value t calculated as 0.2499. So, definitely it will have more value. You can always decide on how many decimals that you are going to round it off. So, essentially if you go for 2 decimals, so it will be basically 2.5. But anyway, keep this in mind that this is 0.2499. So, this is t calculated. Now, you just recall our discussion on the critical value, critical test statistics. So, for that we need to understand the critical value, this is corresponding to the t distribution, and for that we also need to calculate the degree of freedom to take the appropriate value. So, in this case the degree of freedom is nothing but the n minus 1. So, where n was 10, so 10 minus 1 is 9. Now, this is the T table, you can get it from many sources. So, let us focus again, it is a two-tailed test and then we have to check it at 5% significance level. So, that means here 5% significance level means we have to look at this particular column. Now, we will look at those row where degree of freedom we have to check for 9. So, first you determine the column where it is 5% significance level and then this is the degree of freedom 9 for this case. If suppose the sample was something like say 12, so in that case we have to look at 11 etc. right. So, with that if you go and try to intersect this particular point, so the t value that we are going to get, the t critical value is plus minus 2.262 right. Now, we have critical value more than the calculated value, or in other way we have this calculated value less than the critical value. So, if you recall our hypothesis testing discussion in terms of critical value comparison. So, if your calculated value is less than the critical value, so we cannot reject the null hypothesis and we have to accept it. So, that is why it is failed to reject the null hypothesis. So, that means what was our null hypothesis? If we go back to that particular null hypothesis, so it is the hypothesis where the population density in the hill city is 90% per hectare, and then that is something where we cannot reject it. So, that means we have to accept. So, yes indeed it is 90. Okay. Now, I will give you another one in this particular case. So, it is about the Pearson correlation coefficient. So, where you are trying to see the correlation between two variables, and two variables are say x and y right. So, you have two set of information corresponding to x there is some kind of y value, or corresponding to y there is some kind of x value. So, if you just try to make a particular comparison about your speed and density. So, definitely in those cases what you will get that whenever there is some sort of high speed, so you have a less density, and whenever you can say the density is too much you cannot achieve the speed. So, there will be some sort of relationship something like that. So, in this case also the set of data, so each individual data for x is representing by xi where it is x1, x2, x3, there will be a mean value, arithmetic mean. So, sum total of all individual value divided by total number of observations, and then y similarly you have y1, y2, y3, and finally you will get the mean value for the y, and then again it is the same thing where we are trying to take this particular denominator as the product of sum of square difference of two variables, and then we take the square root of it. So, in this all aspect, if the final value is coming to be something in minus, when it is minus 1, so it is a strong negative correlation, because this correlation the value can be from 0 to you can say 1, but depending on the relationship it can be minus 1 or plus 1, but if there is no correlation ideally you will have the 0 value right. So, maybe in this case I just erase this part right for your clarity, and then if there is some strong correlation between two variables the value will be plus 1. So, this is ideal, but normally you will not get those kind of value like 1. So, it will only possible when all the value matches to each other, like increase in 1 is actually increasing 1 to the other, something like that. Say one example if we just try to understand from this. So, maybe population density as dependent variable. So, there might be some sort of geographical variables that may influence the density, it may be economical variable which can be like the income opportunity, employment, or maybe you can say the based on the other important economic aspect, or maybe it is something climatic condition, that it is too hot, or maybe it is something that too cold, or maybe it is like in a rainy area. Consider you want to test how population density in a city is affected by different variables, and we are focusing on certain example here, where we are making the null hypothesis as there is no significant relationship between per capita income and population density in urban area. And then alternative hypothesis, yes, there is a significant relationship between per capita income and population, right. So, in this case, first one, there is no significance. So, even if you have higher income, the density will not make any kind of change, and this case alternative, yes, there is some sort of relationship. Now, for that, again it is some sort of you can say hypothetical data. Actually maybe the relationship vary depending on the location and all, but depending on this, again this is some sort of what data for a study region, and then this is the income, where this is the values like where you have 12,500, and then there are some values 64,000, and then this is the density. Okay. So, in this case what we need to do step by step, if we go, so we have to create the table, okay, in that sequence. So, first you have to find out the difference of between the individual value of each variable with its corresponding mean value. So, for x, suppose income is x and density is y, where y is a dependent variable as we mentioned. So, we calculate the x bar and y bar, the mean income and mean density, and then we try to find it out. So, how we are calculating it, as I already mentioned. So, it is nothing but 12,500 minus 33,950. So, it is coming with minus. For density, the mean density is 141, and in this particular case the density value for ward number 1 is more than that. So, we are getting a positive difference of 84. Then this is something that we require the product of these two, where we are multiplying, and it will be definitely also taking about care of the sign of those individual difference, and then we are getting a value, and then this is the sum total of the product of difference of individual variables with the mean. If you make sum total of this or this particular difference, again it will be 0. So, we do not require it. Then if you see the denominator, so you have to calculate the x minus x bar square, and then also the y bar square, and then you just take the product of this. So, with that calculation, definitely step by step I have shown here, you can cross check, you can take any other value. So, after calculating it, the R value as minus 0.945, okay, and it is something representing the negative 94.5%, and this correlation is significant at 0.01 level. So, that means it is almost, you can say that 99% confidence interval. Earlier we are taking all those call on 5%. So, the value were like at 5%, but here it is like 99%. So, if you perform this in Excel or in SPSS or any statistical software, you get all those significance value. So, as because it is significance at this particular level, so that means we will reject the hypothesis, the null hypothesis, where we assume that there is no significant relationship between the per capita income and population density. Here we are having a relationship, and it is very strong because it is almost close to the value 1 minus 1, right. But the relationship is something like that. If you have higher income, then density will be lower. Okay. Again I am telling you this is just a hypothetical data, maybe in some region you may get some different value, but as because the value is something very high and at 94.5%, like you can say that the value that are giving this kind of relationship, and also it is significant as 1% significance level. So, we reject the hypothesis stating that there is significant impact of income level on population density in that particular area, and also additionally because of the sign we can say that increase in income level will reduce the number of people in a particular area, right. So, this is something where we can reject it. Now, coming to this particular summary, we understood that where to take the parametric test and how to check it. There are different test statistics that you can use. It can be Z table, Z value, it can be T, it can be F, it can be also some something like you can go for the correlation value, or it may be something you can for Pearson correlation, and like that there are other few parametric tests available. So, I suggest you for that reason, if you are interested, normally most of the cases in planning and architecture we confined with all this T value, Z value, or maybe to some extent the ANOVA, but there are other few tests that also you can perform. You can go for regression, you can find out the those kind of R square value, or depending on different estimation you can also check those value, right. So, you can refer, my suggestion that you can refer any good statistical book, and I will also share some of them in our forum, so that you can refer to those, or there are other contents also available where from you can understand different type of parametric test and how to check it. And here also we have discussed two examples. In the first case, definitely we are trying to understand with this particular T test, and where we have seen that as because the calculated T value is less than the critical value. So, we fail to reject. And in the second case where we have seen that it is significance at even 0.01, or you can say that at 1% significance level. So, we can reject the null hypothesis, and in both the cases those examples or the values, they are like taken hypothetically, maybe in reality the relationship may differ. So, in order to make you understand about the process, I have just taken those examples and show and I have shown you how to calculate and take a call on null hypothesis, right. So, with that we are ending it here. So, you can also get all those state statistics and other details in all those books. So, you can refer these books, and also you can refer other content as well. So, with that we end here, and we will be now going to our next discussion in next lecture 38 on non-parametric test. Today we have discussed about parametric test, but at the same time whenever your data is not showing any sort of distribution and the data is something ordinal. So, definitely as alternative, or you can say that synonymous to the T test, or you can say the other parametric test, you can go for those kind of non-parametric tests. So, we will be discussing in detail in our next lecture. Thank you for joining, and we will be meeting in our next lecture soon. Bye bye.